His curatorial projects include a history of bioreactor designs for the Yerba Buena Center for the Arts and the Critter Salon. He has created commission works for the Exploratorium Department of Living Systems, the Kunschel Dusseldorf, and the Otzbo High School in Napa, California. So without further ado, Philip, we're very excited to hear your talk.
I'll just make sure that you can hear me. If you could just kind of, before I prattle on something that we're doing okay. So thank you for inviting me. Thank you for putting this together. This is very exciting. I listened in yesterday to most of the talks, and it was really interesting. As advertised, my name is Phil Ross. I'm the CTO and co-founder of MycoWorks. And I'm going to go on today about a bunch of stuff. I thought I would start though. Vinay is going to play a short 2-minute video that MycoWorks just produced that gives some outward concept of what our materials are like. So I want to start with this so it just maybe gives us a little bit of a reference for some of the things I'll be talking about.
Interwoven, abundant, mycelium connects and sustains organic life on Earth with its extravagant tapestries of microscopic threads, like electricity, like water. It's a dynamic and powerful aspect of nature. Introducing fine mycelium, a technology exclusive to MycoWorks. Fine mycelium engineers mycelium cells as they grow to create three-dimensional structures that are densely entwined and inherently strong. Fine
Okay, I don't know, the sound for me conked out about halfway through, so I don't know if you heard everything that was on there or not. But anyway, this is the outward facing communications that MycoWorks just recently produced to give some idea about a little bit about our process and how we grow our composites from pure mycelium and a textile together to be able to create things for the fashion industry. So I'm going to share my screen and start in with this slideshow. So again, I'm assuming you all can see this now. I'm just not hearing anything. So
we can see.
Great. Okay. So I'm going to take you through a little bit of the background for some of that stuff there, that very science fiction-y, synthetic, imagined computer world, and get a bit more into the nitty-gritty of how stuff like that happens. I've broken this down. My talk today is requirements for mycological infrastructure. I've been the CTO. We founded MycoWorks about 8 or 9 years ago, and prior to that, I had another 20 years or so of experience of working with mycelium materials in one form or another, as an artist, as just as in a lot of different roles until finally getting to this place today. So I want to tell you a little bit about what it means to manufacture with mycelium, the approach that Mycoworks has taken in working with these sorts of leathers. I know that a lot of the people here today are going to discuss maybe applications in engineering for architecture or interior design or other sorts of stuff like that. So I'll describe a bit more about the specificity of ours. Elise yesterday went over quite a bit about how to make these types of composites from the aggregate or wood chips or other sort of waste plus mycelium. And ours is a slightly different process. So I'll get into that a little bit. I'll describe some of the things that we've encountered in our scaling of our process, in the scaling of our company, in the scaling of the people that we have, and how over the course of the last 9 years we've gone about validating what we do into various different dimensions and areas. And then I'll spend the last third of this talk today elaborating why we can't have nice things yet. And this is almost the same kind of subject area when I went to the Lafarge Holcim Foundation and I gave a talk when they were looking at the crisis of cement and its impact on resources in the environment, and described to them why we are not quite ready for architectural engineering materials and the challenges or the impossible barriers that we faced in trying to do this for many years ourselves. So to just sort of again give how some of the abandoned paths that Mycoworks encountered and then left as we approached the challenges of scaling. So this is the Ganoderma lucidum mushroom in the wild, or a cousin of it that is native to the United States in the Northeast, this particular specimen. And these are pretty ubiquitous wherever you have trees, pretty much, but usually hardwood trees, you'll find a Ganoderma pretty close by, or some close relative that can also digest the sorts of trees that might be growing around wherever you are right now. So this is the preferred mushroom that Mycoworks has been using, as well as some other varieties, and we transformed the tissue from such a thing. This is an image from the first customer release using our materials, Hermes's sort of carrying sports bag for men, and these side panels, and now a greater part of these bags are made from mushroom materials that were created specifically for Hermes and in partnership with them over a 3-year development period. So this is the impetus and the background as to what's driving our business, is being able to provide for customers at this point in the luxury leather industry, and going into fine leather applications, couture, high-end, sort of all the categories from again, accessories into all shoes, all the other sorts of things that one can imagine being made out of leather. We see great interest and fine development going on in these fields. We feed our mushroom. The source of its carbon and sugars comes from waste stock. This is from wood mills in Northern California. It's a mix of hardwood and softwood sawdust. So this is the sort of the baseline of one of the value chain of creating these materials, is using relatively fresh agricultural waste or waste streams of materials that have a high composition of lignin or cellulose. These are pasteurized, that is steam cooked, and then we feed them to the mushrooms, these bulk piles of materials, and then the mushrooms spread across them and they start to digest them and transform them into their own body, as well as all the constituent biochemistries that make up that body of that mycelium are now have been created within the material as the biological process itself. So it takes the idea of how we fabricate a material, which has various different trajectories as to which it can take form in our world, and particularly with planar materials, we usually weave these, or we make them from a solid hide like that of an animal, or some other type of polymer, as we now do with various petrochemicals to create all the sorts of things that we might use as wrappings, as pieces in our everyday life in the modern world. But this actually generates the materials sort of in situ, using the transformational biochemistries of the mushroom and their exquisite ability to put together sugars and constituent smaller atoms and molecules into much more complex organizations, into almost like a liquid crystal polymer, or quasi liquid crystal polymer aggregate as that makes up its body, which has just great diversity in its biochemistries of its constituent enzymes and all these esoteric long chain molecules that it's able to, again, like make from the lignin from the wood to synthesize that into ever more complex, larger macro structures. This is the sort of rawhide that comes about. It is peeled off of a living organism. So it is a skin. It is grown along with a textile, so that it is actually grown together with a woven textile. And this gives us a great amount of control in the final product, as far as its material consistencies, its elastomeric returns, the ways that it has insulation qualities, the aesthetic surfaces and how they feel to the skin are very important in leather. And so these are all the things that we've learned from our customers, from these very high-end leather producers, people who make leather products, to learn about what the aesthetic desires are that reside around animal leather, and coaxing and working with the mycelium to be able to produce that in the various, all the various categories that people have come to expect leather to be able to perform within. These materials, we were told as we developed, that they had to be at least as good as, if not better than, the materials we were hoping for them to be compared to. And so we've been able to do that to create organically derived mycelium with these woven fiber textiles, which can be made from, the textiles themselves can be made from almost anything, to achieve performance qualities that are equal to, and in some cases better than, animal skins. And they're grown in these trays as advertised in that introductory video. So a large part of our design process was figuring out an optimal growth environment that gets away from a lot of the ways that fermentation typically happens at larger scales, which is usually in large 10,000 liters or more, up to 100,000 or 200,000 liter liquid reactors, in which solid biomass is grown, that the fungus is digesting sugars, corn sugars often, and creating floating sort of pieces of tissue, which are then fished out or siphoned out. And in our case, we take solid material, we grow them in these environmentally controlled singular chambers. They are passively controlled. That's a big part of it. So we don't have to use a lot of electricity or cooling or other sort of measures that one typically has to go through. And that becomes our unit, is these trays. And this makes a standard hide that the fashion industry is very happy to use because it is uniform, it has a standardization, and it's tractable throughout the process. There's great transparency in the way that we produce these. So all of the people who have handled this and its entire history is literally like stamped onto the hide. It carries its own history as a a sort of mark on its edge. And we've worked a lot with leather craftspeople to make a material that is called a drop-in, so that it is able to use the exact same sorts of tools, the exact same sorts of joinery and craft procedures that fine leather is expected to do, so that the craftspeople do not have to adjust or go through a large learning curve if they want to utilize this. And so we've worked both with the producers of animal leather. We've worked with the craftspeople. We've worked with mycologists and a whole constellation of really divergent industries to figure out in a collage-like form how to assemble knowledge and excellence to create this new type of manufacturing. When we first started off, I described this, that we were going to have sort of a Fordist factory assembly line. We're going to merge that with like a cheese doodle manufacturing plant. And it was going to be, these industries exist, but they also don't often exist under the same roof. So we're going to use maybe cheese doodle type technology to create Fordist production of material objects, not just for eating. And this is an embossed surface. We create this natural sort of unfinished, like a very close to a rawhide, and then a customer can go and finish that themselves. Or we have the sort of standard impressions. This is the most desired sort of fine leather that goes into shoes and bags and all sorts of other stuff. Very far away from the original skin, and the same is true with an animal skin that might look like this. It might have gone through over 200 chemical process steps to get that from when it was on the animal to when it's on your shoe. It goes through an enormous amount of process engineering to bring leather up to a standard and quality that we appreciate and desire. So that's a little bit, just a glossing of some of what we do at MycoWorks. We make this, we're really focused on making this singular material. We found that there is demand for this material. We have letters of intent and purchase orders and all the other sorts of things that help in making sure that you can go ahead and start to scale up. So there's just a lot of other works that went into that. And that's just sort of maybe showing some of the first third of this talk. Let's see. I'm going to talk about validation and scaling. So scaling money. Why are we even in this business? We were focused on, again, like engineering materials for architecture, for construction, for design interiors for over 5 years. There is enormous interest, but no demand for these materials. So it's a bad business model, and we could not figure out how to compete with commodity scale materials like styrofoam, like oriented strand board, like all the sorts of things that people seem to have. There's a lot of interest in it, but again, like no demand. And this reflects here, this image shows you what the markets are like in fine leather, and then bleeding into performance materials, which MycoWorks is well positioned to put itself within. We've done a bunch of market research and looked at where consumer demand is. We started to find a lot of companies coming to us looking for a source, a consistent source of fine materials that can be used in these applications. And we found that there's at least 3% of the values here are something that people would buy with mycelium in each of these areas. So you might get rid of the polyurethane pleathers and look at the exotic leathers, the cowhide leathers, and performance materials where Mycoworks is going to be a competitor within these realms. And just 3% of this per year is a market where no one is yet occupying that. So this is the motivation for why Mycoworks and maybe the 70 other synthetic leather companies that have come into existence in the last 5 years are seeking to address these markets. There's a lot of money to be made. And this was just taking information from the Material Innovation Initiative, which I think is a really interesting source of the development of these next generation materials that Mycoworks and other companies are developing. And this reflects the investment that is accelerating in this field. We've certainly felt this. Mycoworks closed its last round of investment funding using venture capital raised here in Silicon Valley. We raised what's called our C round, our third sort of official round of raising capital of $125 million. So some of that amount that you're seeing in here, a large chunk of that went to Mycoworks in terms of the money that we raised in this. And that was just, again, like we just closed this, I think in December or November of last year, making the complete investment in Mycoworks thus far, I think is about close to $160 million that we've raised. And most of that was just in the last few years. So this is scaling the money to scale to the markets. Scaling facilities. Less than 5 years ago, this was the location of Mycoworks, which grew out of my art studio. So this is about 1,000 square feet, 300 square meters, more or less, below a garage, where all of the operations of Mycoworks, as well as its offices, its R&D, its production, everything else was happening mostly from here for most of the existence of Mycoworks. We had an intermediary space, which is about a larger garage, about 5 times the size of this one, as an intermediary before we eventually came to our pilot facility, which we currently occupy. This is a shot of one of the buildings. This is in Emeryville, right across the bay from San Francisco. And so now we've gone from 1,000 square feet to occupying about 60,000 square feet, where we have a full-scale pilot line, a fully scaled unit that would go into a Climax factory operating within this for the past year, as well as various other offices and R&D facilities and engineering and other sorts of things and other buildings that surround this. But it's about now, in Emeryville, we occupy about now a half of a city block, maybe combined between this. It was 60,000 square feet, 20,000 square meters that we currently occupy, up from 300 square meters. And the reason why Mycoworks has raised that insane amount of money, that $125 million, what could a company possibly need that for? What are those Silicon Valley people doing? Well, we are just started groundbreaking, and this is not the facility itself, but to build something this large. These 2 facilities represent what we are currently beginning to construct, which is close to 500,000 square feet, or I don't know, what is that? That's like about 175,000 square meter of a large, full-scale production facility. This is being built in Union County, South Carolina. We just have begun groundbreaking. The facility itself will run on solar and hydro energy. And we are going to be working with locally fabricated textiles that will be incorporated into them. And then our waste materials from the production, the leftover colonized substrates that we don't utilize will be used in combination with animal silage to make healthier compost. So we are taking waste out of production from local mills. We're creating a material with almost zero reliance on the electric grid, using very, very little water in this procedure. And creating our waste will then be a net positive for ameliorating other bio-wastes that come about as a result of animal farming that takes place in these counties. So in general, I mean, this kind of is, I think, trying to fulfill some of the ideals of what is described as the circular economy. This has not really been a specific goal that Mycoworks has set out to do, but it falls in line with our central values. And so it's also a timely moment that something like this is actually capable to be funded, and there's this actual market demand and a backwind of environmental interests that help to support the ways that we have preferred to work in our own lives. So as part of that, you know, how we are scaling, you know, scaling our facilities, I'm just kind of, sorry, diverging here. We rely on, now we are at an infrastructural level with a plant that size. So those piles of compost that I showed you of wood chips, we now have to make sure that we have a consistent influx of our own farm waste that's coming in. So we are looking in terms of this of like, where is the best place to situate a factory, a large scale climax factory for doing bioproduction of next gen materials. So Department of Energy published this report, the billion ton report, and they've had amendments and follow-up reports, which was really created for the infrastructure of biofuels. But then again, like certain agencies, federal agencies and other institutions have done a lot of the legwork that helped us in terms of working from some of the maps that they've created in terms of, again, like thinking about where existing biomass is within the United States, where this exists within in relationship to, say, trucking routes, to population areas, to zones where there might be enough people to employ to actually fulfill that factory. Mycoworks currently has about 200 employees, and when we occupy that large scale climax facility, we will multiply 4x. So in this year, we're going to go from 200 employees to 800 employees. So we're starting to think about macro scale issues. Are there enough employees in the area who have the skill sets that you need? How close are you to your ag waste? How much does it cost to ship your ag waste from point A to point B? How close are you to a port? What are the yearly rainfall? All these sorts of things that you have to take into consideration, along with all the other stuff you have to think about in trying to grow anything with biology. These are some of the scaled concerns that Mycoworks is starting to look at, really almost a global, our view now is out from, from outer space, sort of looking down and trying to figure out where is the best place to put a factory of this sort at this moment. Scaling people, as described, like where are the existing mycelium material experts? Well, there are none, or they have to be adjusted from some other industries. So we found that we have to actually engage as one of the other things that we have to lift along with starting a business and all the validations and everything else is actually training the people or training the trainers of the people. So we're starting to work with technical colleges, with job training programs, with colleges that have agronomy programs, anybody who might have the ability to work in helping us to develop this workforce that has fermentation skills. And so that's, again, very different from other sorts of manufacturing jobs. It doesn't require a deep knowledge or even an advanced degree or even a degree necessarily, but it does require specific training. And we found that here in the US, there are very few places that are teaching these kinds of things. So we have to go to the institutions themselves and work with them to develop these job development programs. We're also working with traditional tanneries. This is at Cortidos Badia in Spain, one of the places that works in finishing traditional leather, and the same way that we are working to retroactively train their workforces, which are used to working with animal skins or exotic animals or other sorts of stuff like that, to become people who can help in the finishing process of these new biologically derived materials. We still rely on their craftsmanship, their knowledge of chemistry processing, physical processing. And so we have been implanting our own people into these places for years to understand this and to help in the translation of these more almost pre-industrial revolution sort of craft material development, and in a way that it can actually scale, because animal leather does not scale in certain areas. So we are helping them to collect data and to create a more rationalized approach to a lot of the more objective and qualitative, or more qualitative ways that animal skin and hides are finished for fashion. There's still a lot of this that is really, it is very much, we learned that this, the creation of any fine leather still has a lot of hands-on, even just in the fabrication of the leather itself. It is a long internship craft process that is handed down generation to generation, often without written procedures, but based on the aesthetics, smell, sound, all of the bodily sensations. And we are trying to help to put numbers onto those sensations. Validations. So as important as, I just kind of, again, glossed some of the physical elements and other aspects that we have to scale. Let's just kind of, again, like a short view of that. And now validations, we test our materials extensively. We've been doing this for years and years. A lot of what is called destructive use. Still a large part of what we grow is for testing purposes. So we put them through tens of thousands of rounds of tests that are expected. It's like almost 30 or 40 different sorts of tests that our materials have had to pass and now can. That animal leathers are expected to be able to perform at. We found that nobody will buy material if it is not able to perform. I'm sorry, nobody will buy, no one will buy materials unless they can be performance material, perform like leathers. And we have tested our materials with third parties and published our data. We find that this is important wherever we can. I know that Elisa yesterday was describing some of the complications, as well as some of the other folks, of the siloed bits of knowledge. We are working on LCAs, but it is complicated in terms of how to publish those and to figure out the appropriate context in which to release information, and to how to work with partners in releasing information in certain ways, and which third parties is best to work through so as to create the most neutral informations. So this shows some of the types of tests that we put our materials through, as well as how it compares to. And again, this is 2 years ago, so we've advanced quite a bit since this time. Part of the validation is we are now doing a lot of genomics work. So we have to, this is just a whole other area of things. So including with the, creation of raising money, growing a company, figuring out the operations that actually going into production, we have to go into an information arena in understanding our organism. This is sort of like a snapshot of the genome of the Ganoderma that we are working with. And within this tangled set of interactions inside of here is some very critical information that we would like to have so that we can better understand our process and better control it, and come up with better quality and higher consistencies. So we're working on that. We found that publication is very important for the validation, in as much as having third parties is participating in the scientific academic process. This was one of the first papers. This was, I think, almost 14 years ago. working with Professor Duran from UC Berkeley, as well as Sonia Travellini, as really leading the research and publishing some of the first technical papers on the composites, fungal composites. Patents have been an important aspect of validating and sharing information that otherwise might be siloed into the public realm. So upon the expiration of the patent, these trade secrets and expert knowledge that I garnered over 25 years will then become part of the larger public domain. And then other sorts of publication, working with Vera Meyer as the principal and all these other esteemed mycologists on this white paper that was released a few years ago, validating and valorizing these materials to the European audience and American and European scientific communities as to how these materials can be pursued within those institutions. And this has been incredibly helpful to help for a lot of other people's research, just in terms of, again, that need to validate and valorize this pathway of thinking about wood decomposing fungi and their applications for industry. And then, as I promised, in the end here, I will go into why we can't have nice things yet. And this similar sort of presented ideas, facts, experiences that was given to the Lafarge Wholesome audience for the impediments to a lot of the other applications and things. So, you know, we developed this nice suite of engineerable mushroom synthetic composites, ones that had comps to oriented strand board, MDF, OM, was it? Anyway, all the acronyms, all the weird woods one might make, and into foams and other sorts of materials, and even into panel systems, as you can sort of see on the bottom right, this kind of thing that has a laminated, in this case, bamboo. You know, sort of it's like peanut butter and jelly, mushrooms and bamboo. It just seemed like a no-brainer, or even growing the mushrooms on hemp plus bamboo seemed to strike a lot of, you know, again, like incredible bells of interest, huge interest, but no demand. So we were able to do this fully organically to create these things that are now, you know, made with a lot of petrochemical polymers and other sort of nasty chemicals, like we showed fully organic building set to make most of the constructed environment that you see around you, except for just a few components in the constructed environment. So we're like, ta-da, Shangri-La, we did it. Isn't this what everybody wants? And no, nobody wants it. Or I should say there's no demand for it. These are commodity priced materials. So as much as I showed, you know, that factory that I showed you, 125 million is not even enough to really seal the deal on that. We're going to borrow probably at least again as much from banks and other entities to build out that first experimental factory, a large scale wood processing like an MDF factory or oriented strand board factory that can actually compete at cost, you know, in the marketplace. To actually construct that factory might cost $1.5 to $2 billion to create that commodity. So that's compared to our pipsqueak amount of maybe just $500 million to build our facility. And that is the amount of money that you have to look at. And if there's no demand for it, for a commodity material, and you have not figured out a way to necessarily make it any cheaper than or better than, there just is not a market there. So all the good intentions, even the demonstration of the materials themselves and going through the same rigorous testing, publication, validations in the various arenas, and still there did not seem to be a home. So maybe it's just too early. We can have these materials, but we can't afford to make them with the current ways that we unless there are other things that are introduced into those markets, anti-market things taxes, regulations, tort, whatever, to actually help to spur other markets into being. Seems to be the takeaway that we had. We did the same thing, had to create like all of the devices, all the manufacturing from the ground up of this sort of stuff, demonstration of them into contemporary applications, all the IKEA sorts of things. So again, as a drop-in, nobody has to change anything. Can be glued, fabric, whatever, drilled, and screwed, glued and screwed, same ways. And in some cases to perform better, but again, tested them, all the sorts of stuff that one has to do to demonstrate a material can do something. And I know I've seen this recurring, almost this design approach, or as if there is like, it's not finding a market, and it's not a design, and it's not a material engineering challenge. It is a structure of capitalism challenge, and a regulatory challenge that we have before us, more so than like an innovation. Amazing stuff. We were able to, I would like a house that has that sort of flexural capabilities under that kind of pressure. It's amazing what the materials can do. And then, I don't know, I don't know where we are in time. I have just one last really specific thing. I think that this is an interesting lesson that we learned, lessons from textiles about some of the challenges that are before us. Synthetic biology settles some of the problems I'm about to talk about, but there's also, again, some problems with capitalism that I don't really know exactly how to reconcile. And so we, as I said, we grow our mycelium into and through textiles. So muslin is an example of something you might grow through this cotton, linen, cotton rough fabric. Two different muslins, if they're made by two different companies, are a completely different thing. We thought that there was some sort of standardization in measures or interchangeability in the definition of the term of a textile. And then when we learned about the history of textiles, we learned that even the language is oftentimes not shared of what I thought was a universal description of warp, weave, and weft. It depends on which country you're living in, which part of the world, and maybe even the factory from which you bought that material, that things have completely different names, completely different measures, completely different machines that might go into that. The additives that go into that might be made from different constituent ingredients. And by the time they get to the market, you have this babel of standards and measures, and they're not interchangeable. And it makes it very difficult for people who work with textiles to scale textiles. And why we have problems with organic textiles in industry is because of historic reasons. CNC fly knit is overcoming some of this because it brings, again, a standard operating machinery with standard programming languages that can be used. And synthetic biology also offers this as a pathway towards how we might think of it from a biochemical measure, where there's a shared language, shared tools, shared methodologies going forward as to how textiles might be developed or how any material might be developed. We think about this now as that there's a great need in the metrology of applied mycology, and figuring out how to do that so that you don't have, again, 1,000 different standards coming into being in the next few decades that will stifle the advancement of a lot of things. The answer, I think it is in regulatory structures here in California. That again is like going to be the way that this materials in San Francisco, as you can see on the bottom here, this was like acceptable, compostable, or recyclable packaging. This came out maybe 4 or 5 years ago even. And, here is mycelium materials as one of the things. I don't know that this is, this is a first measure, but California's EPA standards are one of the most helpful things in spurring this industry into being, and the ways that larger manufacturers know they have to respond to those standards. And as California goes, so goes the rest of the world. So that to me seems to be really where most of the answers to advancing biomanufacturing is, in the legal realm, or in, again, somewhere in developing policy policy and regulatory structures that will actually make it so that an individual company doesn't have to do so much heavy lifting. Anyway, that's my closure. Oh, we've been making mycelium bricks for over 150 years, so it would be good if we can figure it out, how to actually formalize this sort of ghost technology that has been surrounding humanity, coming into and out of appearances and existence. I'll just exit with this. Yesterday, Esther brought up, where is the social justice applications? And this was showing how fungus can be used in addressing some of the UN's kind of standards that they've set for going forward, to some of the things that it can be applied towards. As part of that, again, like, I don't know that I specifically have the answers for all or any of these, but it is certainly a consideration, and I would advise anyone who's interested to look at that white paper for further references and guidance as to how to maybe advance. Thank you all for listening. I look forward to hearing your questions and the conversation.
Thank you so much, Philip, for that great presentation. So now we have time for questions. So let's start with the audience in person. Any questions?
Hi, my name is David Trutchell. My question has to do with the comparative cost of these new synthetic leathers to traditional, like high-end craft leathers.
Yeah, we are aiming to be competitive with high-end leathers, but also to mid-range leathers. For ones, I mean, we would like to become cheaper than animal leather, and that is really the ambition in scaling. The factory that you saw there is not going to be the one that will do that, and it will probably be a couple of iterations past that one when we've developed, say, a continuous process or something like that, is where we see that those costs are going to come down. So the arc that we're developing is really sort of maybe following the Tesla model of luxury down. And this is why we found it was actually possible to scale our factory in accordance with the price that we can sell these things at, which we couldn't see doing with any of the construction materials. There isn't a luxury construction material market. So we're going to be addressing, there's a lot of capacity, as I showed, like being able to get 3% of that $40 billion a year luxury market is within Mycoworks' scope, then that is what will help to fund us to build the dozens of factories of that scale that are going to be required to kind of get the order of operations up and up. But yes, that is the ambition. We see that we can be competitive and even cheaper than animal leathers. That's why we've received this funding as well too, is that our funders believe that we have a pathway towards that.
Great. Any other questions?
Yes.
Hi, Phil. Josephine, we met at Solomar.
Oh,
Hey,
hi.
Phil. Hey, I have a question on carbon footprint. So you're growing these not in liquid bioreactors. So if you look at water resource, you probably get a lower footprint there. How do you respond to folks from like a carbon perspective? Because these fungi, they're producing carbon dioxide. I just wondered if you could share any thoughts on that front on carbon footprint.
Yeah, we will be publishing data. Again, it's really sensitive because we're working with certain brands that are very sensitive about any information being released, and that is a driver of our clients. So they are very much interested because we are so much lower than animal. We're about 1/10 of the footprint. Again, like we will. How do you say it? We like to publish things when we actually have the data. So, we've been running our pilot scale operation for a year. So we've been collecting, a huge part of that has just been we have sensors everywhere on everything. We're also producing data in that factory just as much. And so that's really core to how we're formulating some of the modeling for this larger scale factory. So I don't have hard answers. Yes, solid state uses much less water than liquid culture. The fungus converts, they breathe like us, so they breathe out CO2. And in the conversion process from being sawdust into mushroom tissue, they gas off, they breathe out about 10% of their mass as CO2. But then the rest of it is locked up for whatever secondary or tertiary things are going into that. And then the mushrooms themselves actually transpire. So they actually create water. So we actually end up, we might have a net positive on water. But again, we're not sure if we're actually making more water than we're putting in as a result of part of that conversion of the CO2 into a gas. So that's just sort of a rough, but it's, and again, by using local solar and hydro on site and then locally produced textiles, just that also, again, like we have to get the information on those things because we are sort of we're sort of demoing this circular concept. And so trying to get this from all the various players together of what does it mean for the provide, and again, like just showing you the differences between that muslin. We were just shocked when we had to get LCAs from some of our, the people who are providing materials for us, of just like how different one textile could be from another, even though they might look exactly the same. Like it was just sort of like off the scales. It would look like a completely different material, depending on the process of manufacturing for some of the subsets. So again, I'm just rambling, but it's just been a huge discovery process for us as to how to establish standards and measures, I think, or any metrology. It's like just there are so many things that are hairy, as the description, that need to be combed out. That could be the way we describe it.
I like that pun. My name is Max Weatherington, work here at Penn State in the MCL. I have a question about the fungi building materials, two-part kind of. One is, did you do analysis on like the shelf life and environmental stability? And then follow up to that, I'm assuming you guys did some market analysis of like, where would this best be applied as a building material?
Yeah. Very sad. I mean, I did not have any ideas about what to do with these materials. Like it was very much in response to, again, like desire of the peoples I encountered. And I was really working on them for obscure aesthetic rationales. The reason I became an expert is because I was just trying to appreciate their weirdness in a lot of ways with a great observance. And so, it just seemed like this is the biggest carbon sink. This is the largest industry on the planet. These materials, it's very easy to make something like polystyrene, and then relatively easy to get these other kind of synthetic woods. So it's just like, okay, this just seems like the way to go. The volume of biomass that this could sink is just so considerable. So we just worked on that. And it was like so many architects, so many engineers are supremely interested, a lot of visionary things, but just like even, the validation process, we were able to do the tests, the advanced environmental testing, the LCAs, all that sort of stuff. But then getting a prototype building, it had to be on a religious monastery, indigenous grounds, or very wealthy Hollywood people where we could get variances on architectural standards or engineering standards. And then that would go to multi-year, on-site validations and observations, and with, again, with no budget. And, there's just all these kind of structural things that are in the way of making it happen. And then so, panel systems seem like the obvious thing. Ours, the fire rating on the stuff is amazing with no additives. So for fire doors, just seem great. Like there's a big market there. Light fire resistant panels, fantastic, yeah. But then it was just like to scale it up. It's like there's your $1 billion, and you know, like without without a letter of intent or a purchase order or any clear way to bring down the costs on that, no one will invest in the risk of that. And so Silicon Valley is even the only place that is willing to risk on something like the leather, which can maybe have a return on investment with a smaller factory, with a smaller footprint facility. So again, like, I don't see how these markets will develop without regulation. Northern Europe is sort of coming into that, but again, it's because they have much stricter building codes now, and these things can fulfill that, or for fulfillments of utilizing certain local materials, these things, yes. So I mean, like, yeah, once the laws are in place, things will flourish, but there needs to be encouragements or actual incentives for people to even risk the money in venture or anywhere else for that volume. And it's just like getting up that thing of like validation, demonstration, you know, yeah, the material can do it, all this stuff that, you know, to show that it's a thing, but then to hit the markets, it's just like, seems, I don't know how you do that. But it might emerge from England, you know, England, Scotland for sure, Singapore, Israel, the Netherlands, you know, anyone who's kind of up against their material resources and is sort of looking ahead for the next couple of decades as to how they're going to exist materially, are starting to take those things more seriously. But that's just, again, like here in the US, we just have so much land and resource. It's just not a pressing thing here yet. So there is tons of interest, no demand. The leather, there is interest and demand, huge demand. And it was more from supply chain, satisfying supply chain and manufacturing streamlining, you know, even starting before Corona, that's really the answers that we are providing to industry, not because of any environmental considerations or desires for any more righteous paths. It's really business concerns that are driving it. And so that, you know, was an actual thing that people would be willing to pay for, as a solution to standard materials that can be delivered on time. And you can't scale leather to match certain globalized expectations of on-demand luxury. And our material can satisfy that sort of new quality expectations and markets. You know, it's been a very weird path for sure.
Hi, my name's Jen McElady. I'm at Penn State. I'm a microbiologist, but not a mycologist. Nice to meet you. I've already placed my bets on your answer, but I'm going to ask the question anyway.
Okay. I want to hear you. I want to hear your answer.
All right. So you started out just sort of in awe of this Ganoderma, you know, object organism. And there's lots of other organisms out there to be in awe of. And so I'm wondering whether or not you're tinkering in your old basement garage with any other organisms.
Yes. Yeah. It's funny. I mean, you know, I'm like a long lineage of humans who became entranced by Ganoderma. It's I'm not the first, I'm not the last. It just is enticing to human. It's shiny. You know, it's like a shiny thing in the forest. So, you know, humans just always find shiny things interesting. So it's, you know, I fell into that trap. So there are a bunch of other ones. The validation process is for Ganoderma has been, I didn't even go into some of the, you know, like the health safety things that we have to go through. You know, the allergy testing, all that sort of stuff. And then, you know, I showed this, like someone else mapped this genome almost a decade ago. You know, it wasn't our group that did that. So we're relying on, you know, a lot of work of other people. And again, like just established things. So there's been a lot of work on Ganoderma for over a millennia. And just so that track record is awesome and just gives us a huge help in advancing the tech. And again, like just, you know, so many people did so much work on that genome already that we can build upon. And if we were to take some of these other organisms that are really interesting and really promising, like, again, it's sort of like just the load lifting is so heavy to, from what I've learned, just to validate Ganoderma into all this stuff. And so to start with one of these other ones, the SOP, the standard operating procedure you would have to write for it, we took, just for the Ganoderma, we took my personal craft relationship has been turned into like a 600-page operating manual of, how to live with a Ganoderma. And so you would have to sort of formalize a similar thing with any other organism. It's just like that, the care and handling of it. And then in all those different directions, into its safeties, its performance, how all these different variables that you have to, all these quadratic sort of variables that are going on, humidity, temperature, nutrients, all this sort of stuff. And then towards, and then what the genetics carries with it, like it's just, it just spreads out in so many. All I'm saying is, yeah, we are tinkering with some other stuff, but it's like, it is, again, like it's a lot for any one business to lift in getting something off the ground. So it's really interesting in starry-eyed researcher part of me, and I do continue some of that, but like the business is just like, I've had so many blinders put on me to keep me just focused on Ganoderma leather. And that's the organism is amazing, and all the organisms are amazing, and the kingdom is amazing, and it's just like, but it's like you could live many lifetimes just walking through the museum.
Great. Thank you so much. So what we're going to do is break for 5 minutes right before the panel discussion. We do have a lot of questions on Zoom, so I promise we'll get to those questions in the panel discussion. So yes, let's break for 5 minutes and then we'll start our panel. Thank you so much, Phil.
Great, thank you.